Finally, let's start. My name is Anders and I work for Linaro in the LKFT team. I'm going to talk about reproducible cross-compilation and cross-architectural testing. And the mission, I'm going to set the scene by talking about what we do in LKFT, and then I'm going to come into this bits. And maybe I should start saying something about myself. I like to be a canvas for my kids, and I send various patches to the kernel, and I hate testing. I love to automate testing. I don't know, is there anyone here that likes testing? Likes to automate it? Ish? Yeah. So, LKFT, the mission is to test the Linux kernel on, I have a slide, on LTS, latest release, and mainline and next. And we are running this on hardware, x86 and ARM, various flavors of ARM. We don't have enough hardware. That's why we virtualize it as well. And we started off by not running that many builds and boots. Now, last year we actually managed to do a lot more, roughly 3.4 kernel builds per minute, and 380 something tests per minute across the whole year, which is a bit more thanks to cloud and to the open source tools that I'm going to talk about today. It's not my drawing, by the way. So I'm going to talk about a kernel builder and basically a wraparound QEMU, Taxon. But let's start. What's the problem with cross-building? It's just use make. That would be easier, right? But it's not that simple. Since we do a lot of builds, there are bugs in the kernel. We find regressions. That's the mission, to report back to the community. And every time we do build on Debian machines, but there are different versions of GCC. So for instance, I'm on testing. I have GCC 12. I report that on ARM on today's next. Then I get the question back, how can I do that? How can I test that? I'm on Bullseye. That creates a lot of frustration for me that reports it and for the community as well. For instance, Jesper. Right, I'm ahead of myself. So that's when we started to create this little project called TuxMake. It's a thin Python wrapper around make. We always cross-compile. Doesn't matter if we build on ARM or on x86 machines, we always cross-compile. It's available as Debian and pip and RPM packages. And it's open source, of course. Supports multiple tool chains and multiple architectures. We have a lot of tool chain runtimes that basically are containers, and they are put together architecture plus compiler version. So here's a command line to build ARM64 with GCC 12. And then it picks the latest container. And if I report this problem a month ago, then Ian, you can reproduce that by taking the container digest. And then you can also set a few, the timestamp for instance, and then we set a few other defaults like host and user. So you can actually get the identical binary, which could be good, but most of the times it's not that great because you don't need that. And we have CLang and GCC and actually Rust, but that's broken, so I'm not going to talk about that. And a lot of architectures as well. Right, and I spoke about the same defaults. We have unique build directories, so when I see build failures all over next, I can reproduce them on my machine at once and then grab a coffee and then get back and look and see how I can fix that or report it upstream. We have some extra artifacts like they've produced config file, logs, and in the metadata file you have all the tools versions that is used to do this build, plus the container digest and timestamp and so on. And again, I went ahead of myself a bit. So here's the way to reproduce the exact build. And we also have a way to do Git. Is brilliant because you can bisect with it, and that's what I do most of my days. And git bisect run I love it. It's easy, but as you just say, you can go down the wrong path as well. But most of the times it actually helps, and I can do a bisection and I can throw on taxmake to it, and that will give me the fault commit. Can do even more funny stuff. I can count warnings and say if the warning count gets up, then it's not great. It's the same thing with testing, but it's a bit more tricky because you have root file systems that you hook into it, and everybody have different root file systems, and you build it in different way. Open embedded, for instance. If I now report that DIO 18 fails, I have to write a lot. Of course, I use taxmake. I say, here, you can reproduce it like this. And you QEMU version and LTP version. That should be enough, or I'm missing something, right? What do you say? What do I miss? Yeah, sorry, I said tag. Yeah. No, but you're right. I should have written that out, but I forgot to add that today. Today's tag. Anyone? What do I miss? Yeah. Host architecture could, yeah, why not? I was actually thinking about root file system. Because I can build my root file system with open embedded, like I know a few of you are doing. Okay. Sorry, I was, my head. So that's always what I get back. But with Taxron, it's also containerized, portable, available as pip and Debian and RPM. But we also support user space, default user space from, I think that is build root. And then we have pre-built Debian root file systems as well. Because we can build, with the TaxMake, we can build K-self-test and all of those user space tools. And if you take those binaries and run them on open embedded root file system, then you will find really fun bugs that is hard to figure out what it is that happens. So that's why we also support Debian root file systems. And we have a few tests that we support as well. A lot of devices. And also ARM's FVP model is possible to run in here. And this is the typical command line. So we hide a lot of QEMU's command line, right? But you can add that add extra bits to Taxron as well, so you can tweak the command line. Yep, I told you about Buildroot and Debian. We also package LTP and libgpio-d, that test suite. And K-self-test is part of the kernel, so when we build the kernel, we build K-self-test as well. And here are some artifacts that you can specify. So if you need DTB root file system, obviously you need, if you want to specify your own one. And QEMU, we can test, we build and publish QEMU's latest versions as well, and also from their master. And actually today I found a bug when running LTP on 7.2.2, where it's fixed on master. I haven't been able to verify if it's fixed in 8 or not. But it helps a lot to nail down bugs in QEMU as well. And there are regressions in QEMU as well. Here are a few examples. So either we run LTP syscalls and we can change the timeout depending on the host machine you run on, because it can be slow if I run it on this machine or if I run it on my server at home. I specify, I forgot to say, the runtime part is Podman or Docker. And it's the same for TaxMake. And you can also not specify a runtime, and then you get everything from your system. And you can save some files. Or you can run just DIO18. That speeds up the bisection if you want to bisect. And I think that's what I'm going to talk about now. That you can chain these ones. So you can actually here run the whole test suite. I'm not going to talk about that. I'm going to talk about DIO18 instead. So I do git bisect good bad. Sorry, bad good. And I do git bisect run, and I threw this cursing on it. And you see, we have a result hook in taxmake, and in there we can throw on taxrun. That reports back, and when taxrun fails, it reports back to taxmake, that reports back to git. And with this I can actually find the faulty patch. And we have the taxmake directive, so with the result hook you can throw on taxmake to taxrun, because then you are inside the artifact directory. And here we had some color as well. And you can add you can look if you find this and then fail. So now to problems. What do you think is the problem with the kernel when I build only with GCC or only build Clang in a container? Is that a problem, or will that work? For the kernel, might work. It works. For the tools, does it work? What do you think? It works straight off, Jesper? Sorry? And for instance, perf doesn't cross-compile with Clang. K-self-test is another beast with a lot of fun issues. I think it's BPF inside K-self-test. You need to have Clang nightly that we build every day. So works-ish, but then they have other tools like, is it Pi-hole? I think it's Pi-hole. PH-hole. Yeah, PH-hole. Yeah. Say that again.
Say that again. Yeah, so the BPF subsystem is specifically bad with having a requirement to having the latest LLVM compiler, or else the self-test simply blows up in your face. And
yep.
I've raised it multiple times, but Alexi doesn't agree with me.
Nope. I think you have Björn. Hey.
You want this?
Oops. What do you think about K-self-test and Clang and GCC and all the different copy-paste?
Yeah, I guess, I mean, you and me spend a lot of time just getting the cross-compiling to work, and it sort of breaks every time you
Yes.
try that. But it's, I would encourage more people to actually try to cross-compiling, especially for RISC-V, of course.
And
exactly. Maybe the thing is that maybe we should cross-compile x86 for all the time on weird platforms. Maybe that would catch some more bugs.
TuxMake, we do that with TuxMake. We cross-compile x86 as well.
Oh.
Everything.
Does that work?
Sometimes. But I think why it works is it picks up the wrong wrong bits, because you're on x86 as well, if that makes sense.
So I asked earlier about the host. You always use x86-64 as a host because there shouldn't be, but sometimes there are differences that depends on the actual host from where you compile the cross-compiler. There used to be, I think there still is, if you have a 32-bit host versus a 64-bit host. But, well, nobody uses 32-bit host these days, I guess. But still between different architectures. So do you always use x86-64 as a host, or?
I would love to say no. And we're working on, so I can't say no. I would love to have ARM as well, since I'm from Linaro. But right now we only have the host as
Okay, so you have
x86.
that fixed.
Yeah. Right now,
Okay.
sadly.
How extensible are the tests in the tax run? How easy it is to provide another bunch of tests? Is there any specific API that you need to comply with, or?
Sorry? Yes, exactly. So these are the tests that we support right now. But give it your own root file system and cd into whatever directory and run whatever script you want, or use our root file systems and use the overlay.
And that should be good enough.
As long as zero success, right?
Sorry?
As long as zero success.
Yeah,
Yeah, yeah.
exactly.
So typical return codes. Okay, awesome.
Which I didn't mention, there is a project called Test Definitions on GitHub, on the Linaro namespace, which is used in Taxon and another project, another framework called a scheduler called Lava. Since Taxon is based on Lava's dispatcher in a container. And this test definition repository, you can run it on desk, or it gets directed from a YAML file that is placed in the same directory, like automated Linux K-self-test. You have a script and this YAML file. And Lava understands the YAML file, and I can run the SH script on my computer here. And that's also open source. So patches are welcome.
Thanks.
So what's typical state of the day? Do you have a clean baseline, no bugs, or do you have to keep track of known bugs?
We keep track of known bugs, yes.
Okay, so there is a non-zero set of bugs that you...
We run this in a cloud environment, and we run them in parallel. So every push to every release, I think we do 700 builds and 1,300 boots, and where we run different tests. And we do that roughly within 50 minutes. We get back results from that. And we push all the data to a database, which is called Squad, QA-reports.linaro.org, I think it is. And there we store previous runs, and we do the lookup there. So it's outside of this tool. Did I answer your question, or did I just confuse you?
Well, sort of, but keeping track of the regressions and known bugs and
No, in Taxron, no. That we don't keep track of that in this project.
okay.
So it's you just run a set of commands and you get the result. And yeah. So here we don't. If you see DIO fail, and if you don't correct either LTP, maybe it's the test that is the problematic part here. If you don't fix the bug in the test or in the kernel, you will see that it fails over and over and over and over.
Okay. So is this ready to use for me today if I fix a bug or?
Yeah.
Okay, nice.
And if you have any questions, just drop me an email.
Okay, cool, thanks.
For TuxMake, what configurations do you use?
A lot of them.
Sorry, what?
A lot of them.
Okay, how do you make a lot? Random ones, or?
And no, we don't do rand config. I do that from time to time because it's fun. Find bugs and correct them, but no, we don't have a good way to present that for anyone in the same way. I can spin off thousands of builds and get results back, but then have to go into each and every one or write a good script, and we haven't done that yet. But we take all the def configs in ARM, and I think we do PowerPC, MIPS, RISC. We do all of them that I listed here somewhere. I think we do all of not Hexagon, OpenRISC, but the rest I think we do builds for. And then for right now I think we do RISC, ARM 3264, x86 and i386 when we boot test it. And for that we enable the LTP fragments, the K-unit fragments. We did K-self-test all mod config, what do you call it? K-self-test merge config. And we ran that, but that's a disaster to start with, to try to enable all the configurations and then think that you can even test anything, because that enables too much. And a lot of the tests in K-self-test doesn't need any extra. And if you enable ftrace and so on, and then the kernel will be really slow, and you have to tweak the timeouts to endless, which doesn't make sense. Then we just turn on the ftrace part or net part or BPF instead. That's why.
All yes config?
Sorry?
All yes config?
All yes, and all mod config.
For the regression testing, is that software also open source for the regressions tracking and so on?
We have the database is
Okay.
open source. It's on qa-reports.linar.org.
Cool. Awesome.
Yeah, we talked about similar things a couple of weeks ago in Vancouver about something called KDevOps that also wanted something like that to publish test results so people can look at it, so people can see if a particular thing is if you broke something or is it a known failure, because a lot of the time we do expect tests to fail, right? in XFS tests and block tests.
Yeah.
You add a test first and then you fix the problem, or they're unsync. So there's so much effort going into like just figuring out what are the false positives. So being able to look up in a database like, oh no, it's not only me, saves a lot of time. And I also think like this containerization and like reproducible builds helps a lot, because you don't need to set all of that up yourself.
Yeah, and actually the benefit as I see it is when I report, and you can just take it and reproduce it, and we see the same thing.
Most of the time, you can't say like, no, it works on my system.
Yeah, most of the time we just do ping pong.
Worked where I tested it, right? It does, so that's great.
But then do you also have like specialized, is it all virtual QEMU only, or do you also have options to kind of run it on the specialized hardware, the ARM boards and so on?
Yes, but that's not Tux Run. That's Lava that I mentioned.
Okay.
That's how we started, and then we needed to be able to parallelize it more, because hardware is a limited resource.
Yeah.
But the reporting
is the same. Yeah.
So, that's cool. No? Yeah. I mean, you do a lot of testing on hardware as well, right? On all the different boards you support in.
Yeah.
Cool.
How did we miss this? I mean, everyone builds their own framework, I know. But it's like, this one runs on thousands. I mean.
Yes.
I'm sorry.
No, but this is great. Now not everyone needs to build their own CI castle.
Always.
Got a nice one to live in. All right. Does that wrap things up? You have?
No, I think I'm exhausted.
Well, thanks for all the work.
Thank you.
For the presentation.